vi dot vi. We talked about the commutative property of multiplication holds across a dot product. It does not across a cross product, but it does for a dot product. So those will cancel out. Again, if we were doing a cross product, we would not be able to cancel them out. However, the other two terms would go away. This is a vector cross product, dot product with itself, so this is just VF squared minus VI squared. Vector symbols are not written down here on purpose. And so, therefore, we have our last equation. VF squared equals VI squared plus 2A dot delta S. Some textbooks, I don't see it often, but I have seen some textbooks throw in a fifth equation, but it doesn't serve much in the way of purpose, so I generally leave it off. Yeah, the fifth one is you solve for VI in this equation, plug into here. Questions before we start manipulating stuff? I suspect Austin's the only one I'm blocking here, so it's just Austin.
No worries.
All right. Eventually I will move. Hopefully there are some teachers who can write it this way. So dominantly right-handed. All right, so we have this 10-second journey. Car traveling along the line, so it's a one-dimensional problem. Initially going at 30 meters per second. It accelerates uniformly at 8 meters per second squared for 10 seconds. After the 10 seconds, what's the velocity at the 10-second mark? What's the displacement? At what time does it stop? And what is the distance traveled? Couple of key things here. The big clue that we're using cake formulas is the word accelerates uniformly. That's the code. Could also have said had constant acceleration, but that's just too boring. Uniform acceleration, same as constant. There are 5 basic quantities that we're working with here, and this is going to be true for this and the two-dimensional motion that we will get to in chapter 4 officially. There's displacement. Now you could break that up into initial and final position, but displacement, initial velocity, final velocity, acceleration, and time. If I know 3 of those, I know I can find the other 2. Now on a problem like this, 3 of the pieces of information are given straight in the problem. There are other problems where you'll have to read into it, you have to understand some of the language. We will get to that. So first off, what do we know?
Initial velocity
Is,
plus 30 meters per second.
all right. Now the math people tell us I don't have to put a plus sign there, so why on earth would I put a plus sign there?
Because it's a vector.
Yeah.
What's the last thing? Time?
Time car stops. Now, if I had not put the plus sign, it would be more important for me to state that the initial velocity is 30 meters per second to indicate that it is positive and it's a velocity, not just a speed. All right, what else do we know?
The acceleration is negative 8 meters per second.
All right. And the third piece of information?
The time elapsed, 10 seconds.
Well, I see that the velocity initially and the acceleration initially are both opposite signs, so I know it's going to have to slow down. All right, so find the final velocity. Well, we got an equation right there. Now, occasionally I have students who get into this position and they're going, I have no idea which equation to use. If in doubt, plug into all of them. One of two things are going to happen. One,
Get it right or get it wrong.
well, okay. I was thinking in slightly different space, but sure, that's works too. You get an equation with only one variable and you go, oh, I can solve for that variable now. Hopefully it's one of those. Or two, you end up with two equations with two unknowns that are the same unknowns, and therefore you just solve them simultaneously. Use some of those algebra 2 skills. Or whatever algebra they stick it in now. Algebra 1? When do you do two variables solving simultaneously? Is that algebra 1?
I believe that's 2.
2? Okay. I guess if you're in the integrated math program, it could happen at any time. All right, so plugging into the first equation. Now, some of you can do this stuff in your sleep and you can immediately jump into it. Matter of fact, some of you probably pull out a calculator and come up with the answer and just trusting you're not going to make a careless error. I've seen enough people make careless errors, so I'm going, I can't believe that person missed this problem. I wonder what they typed in, but all I see is an answer, so I guess nothing. They get no credit. Show your work. So Ms. Sasson insists that you start out with writing down the equation, and that is good advice. I don't insist upon it like she does. However, it is good to start with the equation. Now on the test, the equations will be on the first page, assuming that we are still face-to-face. And some people will mess this up because you've got this AT squared and this AT here, and sometimes people just merge them in their minds and suddenly this becomes VI plus AT squared, or VI plus 1/2 AT squared, which is basically this, but dropping the T there. Just please make sure you're writing the correct equation down. So that's going to be equal to 30 plus negative 8 times 10. I don't have to write units because I'm already starting out in decent units here. I'm dealing with meters and seconds. These are really nice units to work with, to the point where I will sometimes refer to them as nice units. These are nice units, and so I know what my answer is going to be. So this is 30 minus 80, negative 50 meters per second. I do insist that you have units at the end, even if you don't have them, keep track of them during the course of it. What does the negative mean?
That is going,
All right, somebody say it over here.
as are in the opposite direction.
Okay. In other words, it turns around. Or reverses at some point. Next one, displacement. Well, I don't know, well actually I know this point, I know this one, so all I need is an equation that has delta S in it. Any one of these three will work.
Third one.
There's the vote for the third one, all right. So the displacement is going to be equal to VI plus VF over 2 times time, which is 30 plus negative 50 over 2 times 10. Doing the fancy math here, I believe that's negative 100 meters. Because it's negative 25 and 2 is negative 10, yeah, okay. And then the time it stops. So at this point, it's a small change to the problem, but this is part of what is supposed to be understood. I didn't explicitly tell you a piece of information. Initial velocity is still a positive 30 meters per second. Acceleration is still negative 8 meters per second squared, but we don't know time anymore. But we do know final velocity. So a simple example of, it's implied when I say stop that the velocity is 0. And so now we're dealing with this, we're solving for time, and so we need an equation that does not have displacement in it, but does have time in it, and we're back at the first equation again. Sorry, you were pointing, I should have given you a chance, Marisol. And so to solve for this one, I'm going to get cocky and just plug straight into the formula. 0 is equal to 30 plus negative 8 times time. Now, one of the reasons why I am plugging in here as opposed to just going straight to the calculator is I want to make sure that my signs work. Because if I end up with a negative time, that should tell me either I made a mistake or it happened in the past. Or it's an impossible problem, potentially, given whatever the boundary conditions are. So I subtract, so I get negative 30 is negative 8t divided by negative 8. And so time becomes 38ths, which is, it does end up being a positive number, which makes sense. And now the distance traveled. This is not just the magnitude of the displacement. Physically, what's going on is the car starts in some spot traveling in the positive direction. It moves in the positive direction, stops, turns around, and goes back. Ends up 100 meters on the negative side of the starting point. If I sketch it out, goes out, comes back, ends up over here, where, so that's positive, and from here to here is 100 meters. So I need to figure out how far out did it go before it's turned around. There are many ways of doing this one, but I know I'm going from 30 to 0 in 3.75 seconds. Seems like the third equation is the simplest here. My average velocity is 15 meters per second for 3.75 seconds, so my displacement, using that equation right there, becomes 15 meters per second times 3.75 seconds. Is it 56.25?
Yes.
Meters. That's not our final answer. All we've done is figured out that it goes 56.25 meters before it stops. And then it heads back. It has to travel that 56.25 meters back to the starting point and then an additional 100 meters in the back. So the total distance traveled, you got the 100 here, you have the 56.25 to stop, 56.25 back to its starting point. There are other ways of getting to the exact same answer. So just, if you've got a way that works better for you, go for it. So 212.5 meters is the distance traveled. Unless there's a careless error somewhere. Which I'm not opposed to doing occasionally. Assuming Marisol's taking a picture.
I am taking a picture.
Yeah.
So,
Tom?
how did you know, other than just, like, looking at the distance traveled, the little graph you made? the
Right.
picture you made, how did you know that it traveled 56.25 meters again?
All right, so I know that the distance, the displacement is average velocity times time. And distance is the magnitude of displacement as long as I don't turn around. So if I just go in one direction, then my displacement and distance have the same magnitude. So I'm gonna present it slightly differently and take this spot. So time in seconds and velocity in meters per second. So 0, 1, 2, 3, 4, 5, 6, 7. So I start out going 30 meters per second, and my acceleration is -8 meters per second squared. That means that my acceleration is -8 meters per second, which means my velocity will change -8 meters per second every second. So 30, then 22, 14, 6, -2, -10, and so on. And I should end up doing it this way. It's a lot longer than the algebra way. Doing this way, I should end up at -50 by the time I get to here. I know that I can't go from positive to negative without going through 0. So somewhere in here, I stop to turn around. And since going from here to here, from 6 to 0 is 3/4 of the way, this would be 3 3/4 seconds. So now for that 3.75 seconds, my average velocity is, well, I just averaged the first and the last, so I averaged the 30 and the 0, 15. So on average, I go 15 meters per second for 3.75 seconds, so just multiply those. Does that answer your question? Okay. Here I did it more formally. I found the average velocity this way, which is in essence what I just did there. Max?
Whenever you found the displacement, you used -50 meters per second for the final velocity. So why did you have 0 meters per second?
Because at this point, when I asked the time it stopped, well, I'm not dealing with the full 10 seconds. Basically, it's a slightly different problem.
Okay.
Other questions at the moment? All right, ball in the air. I threw a ball straight up at initially, although I think it's implied, I don't have to say initially, if I throw it implies that at the point when I release it. At, let's just say I'm a major league player, so let's, 45 meters per second. That was it in the mid-90s. Miles per hour. how high up does it go? So now I have a problem where I've given you one number, and we need 3. One other piece of information that is implied here, but I probably should say it explicitly. Assume I am standing on the surface of the earth. Now, most likely there will be a problem in the first test that does not take place on earth, and you need to adjust for that. We'll talk about where that shows up. So I got my basic quantities here, got my displacement, I have initial velocity, I have final velocity, I have acceleration and time. What is the one piece of information that we are explicitly given in the problem?
The acceleration is G.
That we are given explicitly in the problem?
Initial velocity.
Yep. You're jumping ahead. Positive 45 or negative 45?
Positive.
What assumption did you just make?
The origin.
If you can choose up to be negative if you want to, there's absolutely no problem with that. It does not change the answer. Also implied, how high up does it go? This is from point of release. Since I did not tell you how far the hand was above the ground when it was released. All right, so we have our one piece of information here that's explicitly given. There are 2 others that are implied. So let's first, not wanting to delay Roberto, but let's do that one, the second one. What's the other piece of information that we were given that is not dependent upon the earth?
The final velocity is 0.
Yes. And so that goes along with how high up does it go. If it is not 0, if it's still a positive velocity, given our convention there, if it's a positive velocity at the peak, that means it's still moving up. If it's negative velocity at the peak, that means it was somewhere higher up and then it's on its way down. So this is 0 meters per second, and this is implied in the problem. And the other piece of information that should be understood in the problem, as Roberto said, acceleration.
Gravity.
Acceleration due to gravity, because we are on Earth. Once the ball has been released, the only force acting on it is its weight. And so if the only force acting on it is the force due to gravity, which is weight, then the acceleration is the acceleration of gravity for that planet. Ish. The acceleration due to gravity is not constant. But it's close enough, often enough, that we pretend it is. So we're going to be using the cake formulas as long as this object doesn't get too far from the surface of the Earth. The acceleration due to gravity is a special symbol. Acceleration due to gravity. Is G. Little g. Do not use big G. That is the gravitational constant. That is something different. G is a positive number, unless you somehow have anti-gravity going. Now our acceleration might be negative, but G itself is a positive number. In Winston-Salem, actually where we are right now, G is 9.798 meters per second squared. Matter of fact, they did a study. They've done several different studies trying to find the acceleration due to gravity. They did one with a plane flying overhead, and that data is available online if you can find it and decipher it. But in I think it was the 70s, the first time they did it, and actually in daylight when you could see it, basically about the same elevation that we are right now in the median in Silas Creek, right in front of whatever road that is that cuts in right over there. That's where the spike was. So, Rome, going off memory on this one, Rome, 9.8 meters per second squared. And I don't have, yeah, it's at home, nuts. Death Valley is the lowest that I could find. That was 9.72, somewhere around there. Mexico City was one of the highest that I saw. So the main point here is that it's not constant. However, as long as we're near the surface of the earth, it's relatively constant. It's, we're adjusting here. There's just a small little swing of maybe about 4 or 5%, depending upon where you are on Earth. So if for an Earth problem, 9.8 works. Negative, because we said up was positive, and acceleration due to gravity is always down towards the planet. Mars, I think, is 3.7. Venus is 8.9 meters per second squared on average. Jupiter is 20, somewhere in the mid-20s meters per second squared. The moon, about 1.6, 1.7 meters per second squared. So now we have enough information to figure out how high up does it go. So we're looking for displacement. Seems like the fourth one is the one to use. VF squared equals VI squared plus 2A dot delta S. We are dealing with a dot product here. My displacement is going to be positive or negative. I throw it into the air. Will my displacement, when I answer this question, will that be positive or negative?
Positive.
I hope so. If I throw something in the air, I do expect it to go up. And we said up was positive. Acceleration is negative, so it's in the opposite direction. In essence, I'm going to multiply 9.8 times my displacement, and then the angle between them is 180 degrees, which gives me the negative sign, or I just multiply negative 9.8 times delta S. If it's a one-dimensional problem, I just treat the numbers like this and plug them straight in. So I have 0 equals 45 squared plus 2 times negative 9.8 times delta S. And so I get, I had to pick a number that I can't square in my head. What is it?
Negative 2025. I'm sorry, 2025, not negative. 2025, it's not negative.
2025? When I take it over to the left side, it will
When
be.
you take it over, you're negative.
Equals negative 19.6 times delta S. Divide by negative 19.6. I am keeping track of the negative signs because if I end up with a negative answer for my displacement, then something has gone wrong. Treat the minus signs as the canary in the coal mine. So I end up with delta S being
103, how many decimal places do we need to take out?
2.
103.32. Two decimal places?
Meter.
Meter.
Thank you. And the answer. How much time does it take? Which equation would you use to figure out the time?
Third one.
Okay. Now that we have that, so 103.32 equals 45 plus 0 divided by 2 times time. So my time will be 103.32 divided by 22.5. Which is 4.7? 3? 16689.
4.592.
592? Seconds. Can't believe I missed that. So now, the fun ones begin. I still want to use those, so I'll keep those up there. Maybe I should move the camera back next time and get more of the board. We'll keep that. All right. At what time is the ball 60 meters above point of release? The ball is going to be thrown up in the air. It's going to go up a little over 103 meters. It's going to come back down. I know that I should have two answers for this question, because it's going to hit it on the way up. It's going to hit it on the way down. The average of those two answers better be somewhere around 4.592. So I have some clues already before I even begin. Final velocity is not zero anymore, because we are now dealing with a point that's not at the peak. I do have displacement. It is positive 60 meters, because the question is above the point of release, and we said up was positive. And I'm solving for time. Which equation? Well, since I don't know what the velocity is, the second one seems good. So I have 60 equals 45 times t plus 1/2 negative 9.8 t squared. That is the problem. Just straight plug in. 60 equals 45t minus 4.9 t squared. This is the point where some of students in the past in this course have shown their real weakness in algebra. Please show your work. How do I solve this?
Difference of two squares.
Difference of squares?
Oh, wait, no, never mind.